Hello, in this video we're going to go through this systems of equation problem here. So when we look at it, it typically causes students a little concern for two reasons. The first reason is that there's no x and y. And at this point, I'd just like to remind you that we use x and y because typically we're graphing lines on a Cartesian plane and we're solving for the intersection of those two lines. The process of solving systems of equations works regardless of the names of the variables. You could graph these with a little bit of thought, but it really doesn't matter if it's x, y, a, b, u, v, t, w, anything we want, as long as we have two equations and two unknowns, or three equations and three unknowns, so on and so forth. The second thing that often causes students pause is the fact that the second equation is not in a nice simplified form. So not simplified form. And again, it's not a problem. We just have to take an extra step here and simplify this. So let's call this equation 1 and let's call this equation 2. And the first thing I'm going to do is I'm going to take equation 2 and I'm going to simplify it. So I'm going to expand the bracket, so I get 2u minus 4 equals 6 minus 3v, and watch this minus sign, plus 3. So therefore, I'm going to rearrange this equation so that it looks exactly the same as 1, as in it's a u, a v equals a constant. So I get 2u plus 3v equals 6 plus 3. I have minus 4 there, it becomes plus 4. So therefore, 2u plus 3v is equal to 13. And so if we call this equation 3, I can now set these up. So therefore, u minus 3v equals 5, and 2u plus 3v equals 13. And now we have a nice systems of equation that looks pretty standard, and it can be pretty straightforward to solve. Now what happens here is, remember, we have two approaches to solving systems of equations, algebraically that is. One approach is called elimination, and the second approach is called substitution. Which approach you use is actually makes no difference. You know, often one approach is easier than the other approach, but again, that's often a personal preference and where your comfort level is in your algebra. So if I take a look at this, what jumps out at me right away is that the 3v and the v coefficients are opposite numbers, so negative 3, positive 3. So if I take these two equations and I add them together, I'm going to see that I get 3v is equal to, sorry, not 3v, 3u, u and 2u, and then plus 0v equals 18. So 3u equals 18, so u is equal to 6. So that's a nice little observation there. So therefore, if u equals 6, we can say 6 minus 3v equals 5. Negative 3v is equal to negative 1. V is equal to 1/3. And I'm done. So this is a process to solve using elimination. But another student might have said, well, look at that. The coefficient of the u in equation 1 here is 1. So therefore, I can very easily say u is equal to 5 minus 3v. I'm going to take two approaches here. So now that I've rearranged and isolated, u plus 3v, pardon me. Now that I've taken this and rearranged and isolated for u, I can substitute it into my other equation. So I'm going to say 2 times 5 plus 3v plus 3v equals 13. So 10 plus 6v plus 3v equals 13. 9v equals 3. V is equal to 1/3. Therefore, if v equals 1/3, I can sub that back in. U is equal to 5 plus 3 times 1/3 u is equal to 1. Oh, sorry, 6. Pardon me. And there you go, it's solved. Again, elimination, substitution, it doesn't matter. Now, let's just take a second and go back to the start of this problem. And I said one of the challenges that students see with this problem is the fact that we have brackets here in the second equation, and that could be a little intimidating. And what we said is you can really just go through and simplify. Actually, let's get a different color here just to kind of make things look a little more fun. You can actually go and simplify, and that makes the equation a little easier. So we expand the brackets and group like terms. But again, you don't actually have to do that. If I found u based on equation 1 here, so u is 5 plus 3v, I can actually substitute it right into the second equation here. So notice, wherever the u existed in that equation, I just put 5 plus 3v. And I didn't do it here, but when you're substituting expressions, I like to put brackets around the expression because that allows you to avoid mistakes in terms of specifically multiplying by a value. But in this case, the bracket doesn't matter. So we're just going to say 2, and then so we have 5 plus 3v minus 2, so we're going to get 3v plus 3 equals 6 minus 3v. Remember, distribute this negative 3 in, so we get plus 3. So we get 6v plus 3, distributing the 2 in, is equal to 6. Oh, let's actually simplify this. 9 minus 3v, so 9v is equal to 6. So v is equal to 6 over 9. I've made a mistake somewhere, so let's take a look and see where I've made my mistake. Do you see where I made my mistake? Right there. So I'm not going to redo this video because it's always good to catch our mistakes. So there we go, so that's a little better. So let's look now. So if we have 3v is equal to 9v equals 3. Look at me, I'm pausing all over the place here, but that's okay. So v is equal to 3 over 9, which is 1/3. Okay, there we go. So 3 ways to approach this, and again, I'm saying 3 ways, but there's actually lots of ways to do this. But again, don't let the fact that these aren't x and y's throw you off. Just check 2 equations, 2 unknowns. And then you can use your elimination or substitution, whatever suits your needs. I hope this video helped.